Circuits that contain resistors, capacitors, and inductors, either in series or parallel, are known simply as RCL circuits. Specific equations can be used to determine the values of resistance, impedance, current, and voltage in RCL circuits. In this circuit, there is an 820 ohm resistor, a capacitor of 0.0022 microfarads, and a conductor of 5 millihenries. The voltage source is 20 volts operating at a frequency of 40 kHz. To calculate the capacitive resistance in this series circuit, divide 1 by the product of 2 pi, the frequency, and the capacitance. So, substituting in the numbers, we have 1 divided by 6.28 times 40 kHz times 0.0022 microfarads, which equals 1,809 ohms. To calculate the inductive reactance, multiply 6.28 by the frequency by the impedance of the inductor. Thus, 6.28 times 40 kHz times 5 millihenries equals 1,257 ohms. To calculate the total impedance of the circuit, take the square root of the capacitive resistance minus the inductive resistance squared. Add to this the resistance of the resistor squared. Thus, taking the square root of 1,809 ohms minus 1,257 ohms squared plus 820 ohms squared gives you 988 ohms. To derive the total current of the circuit, divide the source voltage by impedance. Thus, 20 volts divided by 988 ohms equals 0.0202 amps, or 20.2 milliamps. To determine the voltage across each component, multiply the total current of 20.2 milliamps by the resistance at each component. For the resistor, it would be 20.2 milliamps times 820 ohms, or 16.6 volts. For the capacitor, it would be 20.2 milliamps times 1,809 ohms, or 36.6 volts. And the inductor voltage would be 20.2 milliamps times 1,257 ohms, or 25.4 volts. Using similar equations, you can also solve for the various current values in a parallel circuit. In this case, we'll use the same resistance values obtained previously for the series circuit. To calculate the current through the resistor, divide the source voltage by the resistance at the resistor, which is 20 volts divided by 820 ohms, which equals 24.4 milliamps. To calculate the current through the capacitor, divide the source voltage by the capacitive resistance, or 20 volts divided by 1,809 ohms, which equals 11.1 milliamps. To calculate the current through the inductor, divide the source voltage by the inductive resistance, or 20 volts divided by 1,257 ohms, which equals 15.9 milliamps. To calculate the total current through a parallel circuit, take the square root of the current through the inductor minus the current through the capacitor squared plus the current through the resistor squared. Thus, taking the square root of 15.9 milliamps minus 11.1 milliamps squared plus 24.4 milliamps squared gives a total current of 24.9 milliamps. Finally, we can calculate the total impedance by dividing the source voltage by the total current, which is 20 volts divided by 24.9 milliamps, or 803 ohms.